Hello guys, and welcome to another video. So in this video we'll be talking about separable differential equations. Okay, so in case you are new here, kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video, and then you like, you share, and then you share you also share your questions with us in the comment section below. Okay, we'll respond to them as soon as possible. Now when we talk about separable differential equation, okay, so what we are trying to do is just keep the x terms of a differential equation at one end of the equation, okay, and then keep the y terms at the other end of the equation. Okay, so you might have an equation with only x terms, okay, and then maybe plus another equation with only y terms, okay, so maybe x terms and then y terms, okay, and then we have our differential, okay, and then that will be equal to 0, okay. But for this we try to separate them, okay, we keep the x terms at one point and then keep the y variables at the other end, okay. So in simple terms, keep this in mind that separable differential equations are like grouping like terms, okay, grouping like terms, okay. So when you group like terms, you keep one form of the expression at one end and then you keep the other one behind, okay, the equal to sign, okay. So that's what separable differential equations is all about, okay. We try grouping like terms, okay. Now, so there is one trick you need to know when solving separable differential equations, okay. So the only trick is you separate, okay, that's when you differentiate, okay. So every differential equation when being solved with separable form has to be written in its differential form. So you remember that first video I went through the general form, the standard form, and then differential form of differential equation. So when solving separable differential equation, it has to be in the differential form, okay. It has to be in the differential form, okay, the differential form of the equation, okay. So now let's move on. So first there are 3 steps you need to know, okay. So you first write the differential equation in its separable form, okay, in its separable form or separate form, okay. You write it in its separate form or differential form, okay. And then the second point is to you integrate, okay. So after separating the expression, you integrate the expression, okay, the expression which has been written in the separable form or separate form or differential form, okay. You integrate it, and then the third one is you insert your initial value problem, okay. So you implement your initial value problem. That's why you'll be given certain values to substitute into the expression. Most of the time it's generally the constant c, okay. So you are given some values to substitute for the c value, okay. So that's where you do you substitute, okay. You'll be given some initial values, okay, and then you do you substitute. Now, so the trick you need to know is that you separate, okay, you integrate, and then you substitute. So you have SIS, okay. You separate, you integrate, and then you substitute. So let's see an example, okay. So let's say you've been given a certain expression like let's say x plus 1, okay, dy, okay, equals x open bracket y squared, okay, plus 1, okay, dx, okay. So now one disclaimer is that once you are currently studying differential equations, it means that you've mastered integration, okay? How to integrate certain expressions and other advanced expressions, okay? So I will not go deep into trying to prove to you how to differentiate certain expressions. I will just differentiate them straightforward, okay? So groove yourself and then follow what's the video, okay? So let's move on. So in case you've been given a certain expression like this, and then you are told to solve it, okay? So first you need to use a technique over here, okay? So you separate, you integrate, and then you substitute. So now you could notice that this expression is being misarranged, okay? So we have x and y's over here, okay, and then we have x over here with dy. Meanwhile, we have to only get dy's and y's at one end, and then only x's and dx at one end, okay? That's why from the beginning I stated that separable differential equations are just like grouping like terms, okay? So let's move on. Let's try to group them. Keep only the x's and your y's at one end, okay? So you are keeping x's and dx at one end of the expression, and then x's and dy's and y's at one end, okay? So from here, all you need to do is your algebra. If your algebra is a bit weak, or your change of subject is a bit weak, you might suffer a little, okay? So you have to brace yourself and then try solving more questions so that you get to understand the concept, okay? So let's try grouping the terms. So from here you could notice that we could just let's say move this expression to this point, okay, and then move this expression and this entire expression to this point, okay? So that's how you can group only the y's and the x's. So let's say we have from here we have x, okay, plus 1, okay, dy, okay, equals x y squared plus 1, okay, dx over here. So we can do this. We can divide here by y squared plus 1, okay, divide here by y squared plus 1, okay. Again we can divide here by x plus 1, okay, and then divide here by x plus 1, okay. These are x, okay, this is x. So now you can notice that this will cancel that. So you have 1 on y squared plus 1, okay, dy, okay, and then this will be equal to this will cancel that. So you have x, okay, on x plus 1 dx, okay. So now we've tried grouping this, okay. So you could notice that we have only y's over here, y's and dy's over here, and then on the right hand side we have only x's and dx on the right hand side. Now what we need to do is integrate, okay. So we will just integrate. So we have integration over here now. So this is where we try integrate. That's why I said that I won't go right into trying to prove how to integrate. So in case you don't know how to integrate certain expressions, there are certain shortcuts you could learn, okay. There are certain cheat sheets, okay, you could learn to sharpen yourself up, okay. So when you integrate 1 on y squared plus 1, you get okay, so you get this will give you tan inverse of y, okay, and then we have plus a certain c, okay. So we could just omit this CY and then just state that we have what, or we could just do it straightforward. Okay, so we have what, tan inverse of what, y. That's when you integrate this. Okay, and then we have what, when you integrate x on x plus 1, okay, when you integrate x on x plus 1, you get what, x minus ln of what, x plus 1, okay, then we have what, plus c. Okay, so let's rearrange this. Okay, so by rearranging this, we can write something like this. Okay, x minus what, ln what, x plus 1, okay, minus what, we are bringing the tan inverse of y over here, so we have what, minus tan inverse of y, okay, equals what, c. Okay, so note that this is what, you've been able to write this in what, the general form. Okay, these are general solution. Okay, these are general solution. Okay, now, so after arriving at this point, you could just substitute your initial value problem. Okay, in case you've been given maybe your c, a certain x and what, y values. Okay, right, so let's move on to a different example. Okay, right, so let's say you've been given another example, maybe example 2, to be what, dy on what, the x to be equal to what, s squared, okay, on, let's say, y 1 plus what, s what, q. Okay, so let's say you've been given this expression, so the same principle will be used. Okay, so you have what, you separate, okay, you integrate, and then in case you've been given initial values, you substitute. Okay, so now let's try separating. Okay, this is also what, again, it all depends on you. Okay, algebra. Okay, so from here you could just notice that we can just multiply this y by the y, okay, and multiply the x by the right hand side of the expression. So we have what, y what, dy equals x cube. Okay, so it means that we can multiply here by what, dy, okay, and then multiply the right hand side by dy, multiply the left hand side by dy. Okay, so when you multiply the right hand side by dy, the dy will cancel the dy out. Okay, so you'll be left with what, s cube on what, 1 plus x cube. Okay, and then when you multiply the x from on the left hand side and then on the right hand side, same thing applies over here. Okay, the dx will cancel out and then leaving the dx on the right hand side. Okay, so you get something like this expression. Okay, this is very, very simple and what, straightforward. So next thing is what, you integrate. Okay, so let's try integrating this expression. Okay, so we have what, s cube, okay, on 1 plus what, s cube dx. Okay, so let's what, integrate. Okay, let's integrate. Now when you integrate this, so this is simple and straightforward. Okay, when you integrate y, you get what, it's very, very simple. Okay, when you integrate y, you get what, y 1 on 2 what, y squared. Okay, then you move on. So when you integrate s cube on what, 1 plus s cube, you get what, 1 on 3. Okay, ln of, when you follow the trend, you could just identify this simple trick, okay, on how to integrate these kind of what expressions, okay? So plus c, okay? Now it's very important to introduce your what initial what value. Now, so from here you can do further what simplification, okay? So we could just multiply 2 throughout over here, okay? When you multiply 2 throughout, so you are multiplying 2 from here and then multiply 2 throughout, okay? Over here, so you get what y squared, okay, to be equal to what 2 on what 3 ln of what ln of 1 plus what s cube, okay, plus what 2c, okay. So this is what our expression will be. So you can just further break this one down, taking the entire root of this expression. We have what 2 on what 3 ln of 1 plus s cube, okay, plus what 2c, okay. But note that is either you keep 2c or just leave it like that, because the c that isn't what going to change anything. It's insignificant, okay, at a certain point, okay. It's insignificant to a certain point, okay. So you can just omit the 2 and just represent the entire of this, okay, with just a c, okay, right. So let's move on to what the third example, okay. You could notice that this is very simple and what straightforward, okay. So let's say for the third example you've been given what, so solve what, you have solved what IVP, okay. Solve IVP with what this expression s squared, okay, minus x, okay, plus open bracket 1 plus 2y, right, then y prime, okay, equals what 0, and then you've been given some boundary conditions, okay. So this is initial value condition, okay. So we have y of 1, okay, equals what 0. So let's do a simple calculation, okay. So now let's try solving it, okay. So you have what 1 plus what x squared, right, okay, minus what x1 plus 2y, right, and we know that y prime is the same as what dy on what dx equal to what 0. So now let's try doing some simplifications, okay. Let's try simplifying stuff out, okay. So let's multiply the x throughout, okay. We are multiplying the x throughout this entire expression. So we have what 1 plus what x squared dx. So when it gets to this point, it all depends on you, okay. It all depends on your algebra, how you can implement your algebra, okay, equal to 0, okay. So from here you can notice that we have only x's over here, but there is another x attached to the what, the dy. So we have to move that x to the point where we can what separate it and come and add it to what our expression containing our what the x, okay. So let's just move this entire expression to this side, okay. So we have what 1 plus what x squared, okay, dx, okay, equal to what a certain x, okay, plus 1 plus what 2y, okay, dy, okay. Now so let's move this x to this to the left hand side of the what expression, okay. So you have what 1 plus s squared, okay, divided by what x dx, okay, equals what 1 plus 2y, okay, dy, okay. Yes. Now let's move on. So from here you can notice that we've been able to group only our x's, okay, and then our y's. That's what separable differential equation implies, okay. So now we can just equate this, okay, to 0. You can equate the entire of this to 0, okay, or you can just integrate straightforward, okay. You can either integrate straightforward or just equate everything to 0. So but we can just go by the form, and let's equate everything to 0, okay, so that our expression will be a bit simpler, okay. So you have this divided by that, the x, okay, minus, we are bringing everything back, okay. So you have minus, open bracket, 1 plus 2y, okay, dy equals 0, okay. So now let's integrate, okay. So when we integrate the entire of this and the entire of this, when you integrate this, okay, when you integrate the entire of this expression, you will end up with what? Sorry, let me clear this one out and let's move on. So when you integrate this, the entire expression of this, so from here we know that, let me simplify this for you. We have what? This is the same as 1 over x, okay, multiplied by 1 plus s squared, okay, the x minus this entire expression, okay, 1 plus 2y, okay, dy equals 0, okay. So now when you integrate this expression, okay, you will end up with what? Ln x, okay, plus this one, okay, s squared on 2, okay, and then minus this expression will give us y plus y squared, okay, equal to c. So when you integrate this, you get y. When you integrate this, you get y squared, okay, because we have, this will be 2, this will be something like this, okay. So this will cancel that, remaining y squared, right. Let's move on. Okay, so you've been given initial value conditions at y equals 1, y into 1, and then 0. This means that y is 0, and then x value is 1. So let's just insert it into this expression, okay. So substituting y equals 0 and then x equals 1 into this entire expression, we have ln of 1, okay, plus 1 squared on 2, okay, minus 0 plus 0 squared, okay, equals c. So when you do the math, you will end up getting your c to be equal to 1 on 2. When you add this one up, you end up with c to be equal to 1 on 2. Now you can substitute your c into the entire expression, this entire expression. So we have ln of x, okay, plus x on x squared on 2, okay, minus y plus y squared equals, okay, let me write this well, okay, y squared, okay, equals 1 on 2. So this is your entire expression. So now from here you could notice that we've been able to go through the entire separable differential equation topic, okay, by using our SIS, okay. So from here we implemented our SIS, okay. You separate, okay, you integrate, and then you substitute, okay. So in the next video we might talk about reduction of separable differential equation. Okay, we are trying to reduce separable differential equations into their simplest form. Okay, so thanks for staying with me in this to the end of this video. Kindly subscribe, comment, share, like. In case you have any question, just ask them in the comment section below and I will reply to them. Have a lovely day. Bye bye.